All right, guys, it's Miss Cameron here, and we are finishing up our packets for ACT math practice. Question number 51 says, what is the slope of a line that is parallel to the line determined by the equation 5x minus 4y equals 8? And I want you to focus on this part right here that says, what slope is parallel? What do we know about parallel slopes? Parallel lines have the same slopes. So we need to take our equation, find the slope, and then we'll have our answer. So this linear equation is written in standard form, ax plus by equals c, and we need to rewrite it into slope intercept form so that we can see what the slope is. So you'll have to have that memorized. Slope intercept form of a linear equation is y equals mx plus b, where the slope, and let me use a different color, where the slope is m and the y-intercept is b. So let's take our equation 5x minus 4y equals 8 and solve it out for the y. So I want to move my y over to the other side to get it positive. So I'm going to add 4y to both sides of my equation. And while I'm at it, I'm going to get rid of this 8 and subtract 8 on both sides of the equal sign. I can rewrite that as 5x minus 8 equals 4y. And I can move my 4y to the front and erase it from the back so that it's a little more looking like this. And now to get the y by itself, just divide everything by 4. And we can look here at our slope, where the m is, and that's everything with the x, it's 5/4. Number 51, the correct answer is C. Then we can keep going on to question number 52. It says, if 3 to the power of 8x equals 81 to the power of 3x minus 2, what is the value of x? Well, what do we know about 81? We can factor 81 down into 9 times 9, and we can factor those 9s down in our factor tree to 3 times 3 times 3 times 3. That means that 3 to the power of 1, 2, 3, 4 equals 81. That's our starting place here. I'm going to get rid of my factor tree. And now continue. Now I can take my 3 to the power of 4 and raise it to the power of 8 x and put that as equal to 81 to the power of 3x minus 2. Actually, wait a minute. Why did I put this here? I don't want to put that there. My bad. Let me come back. 3 to the power of 8x equals to 81 to the power of 3x minus 2. I'm going to take out my 81, my bad, right here. Let me make it pink so I can see. And change that to 3 to the power of 4 raised to 3x minus 2. Now, my base, I have a 3 for both of them. Now I can say that this 8x here equals to 4 times 3x minus 2, and I can use that information to solve for x. And I have my 4 outside of parentheses. That's telling me to distribute the 4. So 8x equals 12x. 4 times negative 2 minus 8. Subtract 8x on both sides. Let me move that over here. That gives me, actually I can also add 8 on both sides at the same time. 8 equals those cancel. 12 minus 8, 4x. Divide both sides by 4. So x equals 8 divided by 4 is 2. Also, I think I can play with the graphing feature on this. And even though this is not a graphing question, I can still put this as 3 to the power of 8x minus 81 to the power of 3x minus 2. And let's just look at our graph. Oh, I still had my inequality on. Let me fix it back to normal. And I just want that normal line right there. Okay. Okay, that should give me a normal line. And right there, look at that. My x is on the 2. When y is 0, x is 2. Ba-da-ba. So even if you can take your equation, play around with it, look and see what the graph is, you might be able to find the answer that way as well. Okay, let's continue. I want to finish this up. It's getting late here at my house. Question number 53 says the picture shown below has a uniform frame with the width of 5/8 inches. What is the approximate area in square inches of the viewable portion of the picture? So this frame is 5/8 of an inch. So that's just this little border piece going around here. So they want to know what is the area not including the picture frame. So we have our our length of 30, area equals length times width. Length, width. Length, our length down here, we have 30, but we're going to take away this 5/8 and this 5/8, so minus 10/8 times our width, 18, up and down, right? Minus 5/8 minus another 5/8 minus 10/8. And let me get out of the graph. We can just put that in just like that. 30 minus 10/8, 18 minus 10/8. Notice how I'm using my arrows, and I want to get my answer as a decimal, not a fraction. Option 2. And there we go. We're on the answer already. Number 53. My son in Algebra 1, he just had to do this for homework on multiple questions the other night from his teacher. Just like that. Number 54. A horse eats 12 bales of hay in 5 days. At this rate, how many bales of hay does the horse eat in 5 plus x days? So if he eats 12 bales in 5 days, how many bales of hay does the horse eat in 5 plus x days? So on the first day, well, his first 5 days, he's eating 12 bales of hay. So that means on day 5, he has had a total of 12 bales of hay. But back on day 1, he had 12 divided by 5. So we would have to say, how many bales of hay does he eat in 5 plus x days? Well, on that 5th day, he's getting 12 bales of hay. And then for every extra day, he's having 12/5 of a bale of hay. So, oh, that's the answer. Because in 5 days he had 12 bales of hay. And then each extra day he has 12/5 of a bale of hay, considering that the horse eats the same amount every day. And then question number 55 says, when graphed in the standard xy coordinate plane, lines x equals -5 and y equals -5 intersect at what point? Well, right away we know no matter what, the x is -5. So we can just graph our other equation here. Y equals x minus 5. And say, okay, well, what is y when x is -5? I can't see it on the graph, but I'll look at the table. When x is -5, and look at that, I'm already on it. When x is -5, y is -10. Another way to do that without the graph would be to just solve by substitution. Take this -5 and plug it in for x. Y equals -5 minus 5 equals -10. Either way, same answer both ways, pretty fast. Question number 56 says, which of the following expresses the number of miles a runner must travel in a 4-lap race where the course is a circle of radius m miles? So we've got a circle, and the radius is from the middle to the edge is m amount of miles. If there's a 4-lap race. So you're going to do the circumference, right? You're going to run the circle. So circumference is like the perimeter around the edge of a circle. Circumference. And if you've studied it all for the CLT, you know this is one of the first formulas that they give you on that reference sheet. But on ACT, they do not give you the they don't give you a reference sheet at all, so you'd have to have this memorized. The formula for circumference is 2 pi r, and we're going to do 4 laps. So 4 laps is the circumference times 4. So 4 times 2 pi r, where r is your radius, and our radius is m. So I'm going to erase these r's and change it to an m. And 4 times 2 is 8 pi m. Done with number 56. Moving on to number 57. For some real number n, the graph of the line y equals n plus 1 times x plus 6 in the standard xy coordinate plane passes through the point 4, 8. What is the value of n? I'm going to come back here to my graph, and I'm going to put that in. Y equals, answer choice A says negative fraction 3/2 plus 1 x plus 6 passes through point 4, 8. Graph, look at the table. When x is 4, is y 8? Not it. And I'm going to change 3/2 to 1/2 to try answer choice B. And I'll look at the table again. And when x is 4, y is 8, we have found the answer by just graphing. If you wanted to go the algebra way, you would take your y equals n plus 1 x plus 6, and you would plug in 4 for the x, and you would plug in 8 for the y. Distribute the 4. Eight equals 4n plus 10. Subtract 10 on both sides. -2 equals 4n. Divide both sides by 4. N equals -2 divided by 4, which equals negative 1/2. So we would get the same answer either way. And then question number 58 says, a computer repair person charges $50 per hour plus an additional mileage fee. The charge for mileage varies directly with the square root of the number of miles traveled. If 1 hour plus 25 miles traveled costs $140, what is the total amount charged for 1 hour plus 36 miles traveled? Well, it's going to be a little more than 140. All of those are more than 140. So we know they charge $50 for the hour. So $50 times 1 hour, and both of these are for 1 hour, plus 25m equals 140. Then we want to know what 50 plus 36m is equal to. And to do that, we got to find out what that millage fee is. So, we can graph it. Y equals let me see. The square root of the number of miles traveled. Oh, because 25 and 36 are both perfect squares. Let me see here. Can we just graph it? Let me see. 25x plus 50, right? That's this. And then I'm going to subtract the 140. Look at the graph. Equals 0. When y is 0, x is somewhere between 3 and 4. And it's a little closer to the 4. Okay, graph didn't really help on that. Let's see here. Let me go back. Another color might help me focus. Let's see. Maybe it's not exactly written like this. A computer repair person charges $50 per hour, and we know they only worked 1 hour, plus an additional mileage fee. The charge for mileage varies directly with the square root of the number of miles traveled. So we know that m is 25. We know that m is 36. Let me change my variable, because it should be the square root of those miles. Square root of 25 and the square root of 36 times x. Let me look at this. Square root of 25. Delete. X plus 50 equals 140. Graph it. Let's look at the table. X is 0, y is negative 90. But when y is 0, x is 18. So x is 18 is what I'm getting from my graph. Quit. So let me check this. 50 plus 18 times the square root of 25, which is 5, equals 140. So now let's pull that back up and change it to the square root of 36 equals 158, which is the correct answer. And like I said, it is a little bit more than 140, $158, because it's a little bit more miles. And this one more, 5 to 6, 18 more. There we go. Number 59, in the right triangle below, YZ is 10 and XZ is 4. What is the sine of Z? And we know sine equals opposite over hypotenuse. Our hypotenuse is 10, something over 10. Our opposite side, our O over here. So we need to use our Pythagorean Theorem for a right triangle. This formula you have to have memorized. A squared plus B squared equals C squared, where C is the hypotenuse and A and B are the legs. So our letter O squared plus 4 squared, O squared equals, plus, my bad, that's a plus. O squared plus 16 equals 100, subtract 16. O squared equals 100 minus 16 equals 84. So, oh my goodness, I can't write what I say and say what I write. O squared equals 84. So O equals the square root of 84. And what were they asking for? What is the sine of Z? So we want the square root of 84 over 10. There's our answer. And I know the square root of 84 over 10 is going to be either, probably C. It's probably C. Let me see. Square root of 84 divided by 10. And I know this one's going to be 0.4. Looks like this. They have it upside down. So I'm going to go straight to C and check that one. Put in my fraction. 2 square root 21 over the hypotenuse 10. We got our match. It is C. And I would just guess and check. Check any of them. Find the one that's a match for 84 divided by 10. Square root of 84 divided by 10. And we have made it to the last question in our packet. Sorry if my explanations were a little less thorough here on this last video, but I told some of my students I would get this out today, and I just started getting kind of tired. So I appreciate your patience with me, and I'm trying my best as well to show patience back to you. Question number 60 says, a triangle ABD is reflected across the line y equals x to have the image triangle A prime B prime D prime in the standard XY coordinate plane Thus, A reflects to A prime. The coordinates of point A are M, N. What are the coordinates of point A prime? So we're gonna draw our coordinate plane, X and Y, because you don't get to have graph paper on the ACT. You just get the paper you're provided with, and there's no graph section. If I were solving this, I would really want to have a graph paper, but it's not given. So I'm going to draw the line y equals x, so that goes through the origin, and it's always up 1 over 1, up 1 over 1, up 1 over 1. So we're going to make 45-degree angle and a 45-degree angle, 45-degree angle and a 45-degree angle. And I did my best to graph that line y equals x right here as I could. And if you need to check, right, y equals x, graph it, that's what it looks like. Now it's saying I don't need to focus on all of the points A, B, and D. I can just focus on any point, no matter where it is, if it's here, okay? A. Let's say that A is, let me just draw on the line some very even as I can get them points. Do those look pretty close to the same size? Maybe. I'm going to go right 1, 2, 3, 4, and up 1, 2. And now I have to use my imagination. Here's point A, and it's getting reflected about this line here. Okay, so I'm taking my purple line, and I'm like, if it's my paper, I'm going to fold it in half. And where does A go? It's going to go right about here. I didn't draw it perfect. But if I did, then you would be able to see if A's points were at 4, 2, then A prime's points would be at 2, 4. So that's why it's not really an equal distance from my purple line. My spacing was a little bit off. So that means that for number 60, what happens when you reflect a point across the line y equals x, your x and y switch around. So mn becomes nm. Answer choice J is correct. And you can probably do a better job of me on paper with this and use graph paper or lined paper and line it up properly. It's just, you see my little spacing here, they're not all equal distance, so my drawing's not quite right, but you can prove it on a better piece of paper. And one more thing, I know we did all 60 questions here, but there was one more thing I wanted to add to this video that you might see on the ACT that was not in this practice test, and that was ACT matrices, practice, whatever. Let's see if I can just see a quick example. Oh, missing matrices. We want matrices question. No thanks, Bing. ACT matrix worksheet, maybe? Let's see what they got. That does not look like it. Not it. Not it. Not it. Well, I might have to save this for the next video. Sorry, guys. I do have an example in class that we will go over tomorrow morning before you guys take your ACT. All right, I hope that you have a great day. I hope that you are feeling well and confident that you're going to go into your ACT doing your best. And I will catch you on our next practice video. Bye.